hope that you are doing well. Stokes and I are again here to help you work through some of these math problems. Right, kitten? Right, little baby? Alright, so let's get started with this. And I actually do want to pause before I say this and say this is the problem set that we're going to be doing for Module 5, Lesson 5. That's the work that goes along with Tuesday's math. So if you're here, nope, that's ELA. Here, right, so we're actually doing this, but the application problem is very similar and will help you with this. So please stop. If you haven't yet done the application problem, please stop. Please go do that. Check it out. And see if you can actually do this on your own. You probably don't need me for this, especially once you do the walkthrough with me of the application problem. Now, what we're working on today is we're trying to be able to find our objective is to find how much liquid a rectangular prism can hold. And if you did not see the application problem, then something that you might have missed, I'll just put this down here for now, is that when we're talking about liquid, we'll often talk about ml, milliliters. ml is milliliters, and for every 1 centimeter cubed, because remember when we're in volume, we just happen to have this cubed, it's confusing, but almost like ignore it, right? If I have 1 centimeter cubed, so if I have the only thing that the cubed means is that it's in a 3-dimensional space, right? It's got length, width, and height. So if I have a cube like this and it's 1 centimeter, it can fit exactly 1 milliliter. So it's actually a very easy conversion. So if you have a tank that is, let's say, 53, it has a volume of 53 centimeters, then it can fit exactly 53 milliliters of liquid in that tank, all right? So that's the one thing you really need to keep in mind for these problems, all right? So let's go ahead and get started reading this. So it says, a small fish tank is filled to the top with water. If the tank measures 15 centimeters by 10 centimeters by 10 centimeters, what is the volume of water in the tank? Express your answer in milliliters. So what do we know here? Well, we know that we're making a little fish tank. So let's draw that fish tank. And we know that the fish tank has it has the following dimensions. It says that it is 15 by is another way of saying times, right? 15 by 10 by another 10. And if we remember that volume is length times width times height, in this case, it already gave us length, width, and height. Because when it's spelling out these dimensions, 15 by 10 by 10, it doesn't really matter which one we use for what, because we're going to get the same volume no matter what. So in this case, I can say the length is going to be 15, right? That 15. The width will be 10. And the height is also 10. So you should know by now, I hope, and if you don't, please come visit in office hours, that when I'm doing volume, it's 15 by 10 times by 10. 15 times 10 would be 150 times another 10 would be 1,500. Now, since this measuring was all done in centimeters, right? 15 centimeters by 10 centimeters by 10 centimeters, then the volume is also, and sorry, this looks a little bit like a 6, so I'm actually going to delete it and just rewrite it as more of a 0. The volume is also 1,500 or 1,500 centimeters, and because it's 3D, it has length, width, and height, imagine like a 3D box, it's cubed. Now, since it says express your answer in milliliters, remember what I said before, that every 1 centimeter or 1 centimeter cubed is equal to 1 milliliter. So if it has a volume of 1500 centimeters, then it will have a volume, or the amount of water that can fit in, is 1500 milliliters. It's one of the easiest conversions you can make. You don't actually have to change the number at all. All you're doing is you're changing your units from centimeters, which is talking about how long, wide, and high something is, to milliliters, which is talking about how much liquid it can be filled with. All right? So now we've figured this out. If this tank is totally full, completely full, from the top all the way to the bottom with water, totally full of water, it has the amount it can hold is 1500 milliliters, right? So let's look at number 2. It says, after a week, water evaporates out of the tank. So the water is now 9 centimeters high. What is the volume of the water in the tank? So now we have a slightly different question. When we started, it says a small fish tank is filled to the top with water. After a week, some water evaporates out. Evaporates, remember, means goes back into the air, goes into a gas state, so it's no longer looking like water in the tank. So if I took this tank that I've got here, sorry, apparently it doesn't want to be grabbed, but if I grabbed this tank and I put it here, so my height would, since it's asking me, the water is now 9 centimeters high, right? So the amount of water that fills the bottom this way doesn't change. That's still going to be 15. The amount of water in the width, that doesn't change. That's going to be 10. But now, and let me actually do that in another color, right? So I've got my volume here. Grab this out. I have my volume here. The water in the tank is not going to change here. This bit here is not going to change. Here is not going to change, right? Imagine that you fill a tank with water. The bottom isn't going to change, but now instead of the water going all the way up, it only goes this high, right? So some of that water evaporated out of the tank, and we can tell that now how high is the water? When we first started, the water filled up all the way to the top. It was 10 centimeters high. Now some water has gone out, and now it's only 9 centimeters high, right? That's what it tells me in the story. It's 9 centimeters high. So now the question is, again, what is the volume of water in the tank? So I can go back to my volume equation. Volume is length times width times height. So if the length is still 15 and the width is still 10, that won't change. But now the height is no longer 10 centimeters. Now the height is 9 centimeters. So I am going to have to multiply 15 times 10 times 9. And when I do that, I will then get my new volume. All right, I hope this was helpful, scholars. I miss you, I love you. Please come to office hours if you have questions about this. I know volume is a new concept, and I'm really sorry we have to learn it from so far away, but the good news is that I am here for you during office hours. Miss Andrea is here for you during office hours, and we don't often get a lot of people, so if you come, you get so much one-on-one attention, actually 2-on-1 because there's 2 of us and 1 of you. But please, please, please come. Please ask questions. We're here. We want to help, and we miss you. All right. Goodbye, scholars. See you later.